Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, here we go with our first lesson for chapter 8. This lesson is called Measurement Precision. This is actually, it's a 2-day lesson, and we're not in the classroom. We're not able to do a major part of the activity that takes a lot of time. So this is actually going to be a little bit of a quicker lesson, and I am going to have you spend 2 days going over the homework. We'll slow down the pace of the lessons as we move forward, maybe do 2 or 3 of them per week. Um, and, pretty much try and do homework 3 to 4 times a week. So let's go ahead, let's get started on this. I luckily have some data saved from previous years, and we're just gonna, instead of us going through and doing the activity, we're gonna look at the measurements that students in previous years have made. So there are 2 terms that I want you to focus on right now. They seem to be synonymous with each other. A lot of times people use these terms interchangeably, but there's a subtle difference in the meanings of these 2 terms, accuracy and precision. Let's start with the term accuracy. The definition of accuracy is, it refers to how closely you hit an intended target or area. I'm going to show you a graphic that is not included in the online book, something that I found that I think is a really good tool for seeing that, what accuracy actually means. And then precision refers to the consistency with which you hit a target, even if it's not accurate. So, if you're dealing with an instrument that's precise, with high precision, it's going to hit a specific target a lot. Whether or not it's your intended target is another issue. So accuracy is you're actually hitting the target that you want to hit, whereas precision is like, oh, I'm getting all my shots in the same location. Okay, so there's a slight difference there. Go ahead and pause this if you want, because I'm going to move to the next page, and then you can catch up with us once you've written everything down. I'm going to actually come to here right now since we're talking about this. These are 4 targets if you think of archery. Okay, so look at this target here. The target that you're trying to hit is the bullseye, right? But this person who's shooting at this target is not, I mean, they hit it once, but their shots are all over the place. So only one of them hit the intended target, and none of them are really in the same location. There's not a lot of consistency there. So it's low accuracy and low precision. Here's an example of high precision. So this person is shooting in a very consistent way, but they're not hitting the target. So the accuracy is not there, but the precision is. And one would think if they could just make a few adjustments, they would get to the bullseye. Here's an example where you have pretty high accuracy. Everything is toward the middle, but some are on the left, some are on the right, some are on the top, some are on the bottom, but pretty accurate, just not precise. And then here's what your goal is, to be both accurate and precise. So here's someone who has made the adjustment perhaps from here. They are now accurately hitting the bullseye, and every one of their shots is consistently hitting in the same location. Okay, so low accuracy, high precision, high accuracy, low precision, and then high accuracy, high precision. Might not be a bad idea for you to draw this graphic in your notes, just to put a picture to these terms and what that means. All right, so do the lengths of objects you are measuring or the tool you choose to measure with affect how precise your measurement is likely to be? In this section, your class, you, or a previous class, you're just going to look at our results, explore this question by analyzing the results of an experiment. As you work with your team, think about the questions that follow. What am I measuring? What unit is being repeated? And what can I do to make my measurement more precise? Because that's our goals. We want to be as precise as possible, and then eventually as accurate as possible. So which tool gives you the more precise measurement? Okay, so what we did is we took 2 measuring tools. We took a ruler, 12-inch ruler, and a measuring tape. And we broke up into our teams and we started measuring the distance across our classroom. And the people would measure twice. You'd have someone using measuring tape and then they'd write down their results. Someone else would use a 12-inch ruler and then write down their results. And then we all sat down and we started to analyze the data. And what we're trying to find out is which tool seems to be measuring more precisely. And then once we determine that, then it's like, okay, can we decide what we believe is the actual length of the classroom? Because, you know, when a bunch of different groups measure, you're not necessarily all going to get the perfect measurement, you know, because people make mistakes. So which tool do you think gave the better answer? So those are the questions that we're going to come back and think about as we do this activity. So as we're going through, we're going to examine the data. I'm going to show you the data that we found. They're going to see if there were any outliers there. And maybe think about what could you do to help see the outliers better. And then what is the range of the data? How do the ranges compare? And then look for the median and then the quartiles. So here is a table that is going to show us the results. Let's start with the measuring tape. With the measuring tape, what I did was I had everyone sit down and then called on someone from each table group, and they called out what their measurements were, and so I wrote them all down. Then we did the exact same thing with the 12-inch ruler. Called a representative from each group. They told us what their measurement was with the 12-inch ruler, and I wrote those down. So at first glance, can you tell if there are any outliers in this data? Is there something you could do to make it easier to see if there is an outlier? Is there something you could do to check for the minimum, the maximum, the medium, or the median? And the answer is yeah. Let's put this data in order from least to greatest. So the measuring tape looks like the shortest room measurement was 30.5 feet. And the longest room measurement was 33.5 feet. So does it look, from putting this data in order from least to greatest, that we have any outliers? And I would say no. It looks like they're all pretty close to each other. Now let's look at the 12-inch ruler, see what we've got there. Their lowest measurement with the ruler was 30 feet, and the highest was 35. Okay, so immediately I'm looking and saying, okay, there's a bigger range here. There's like a 5-foot gap between the lowest and the highest measurement when the groups were using a ruler, as opposed to when they were using the measuring tape, where it looks like there's only about a 3-foot gap in between there. So let's go ahead and follow the directions. I'm not really sure that there are any real outliers in either one of these data, so that's good, because usually when there's an outlier, it generally means there was a mistake in measurement. Here we could just have issues with precision of measurement. How well are people marking as they move the ruler up and down the floor? So looking at the measuring tape, let's look and see what the minimum is. It was 30.5. The maximum was 33.5, and the median right in the middle is 32.5. The first quartile was 32. The third quartile was 33. And let's go ahead, and I'm going to highlight these and refresh your memories of how we find each one of these data pieces. The minimums and the maximums, those are easy to find. The median is the number exactly in the middle, since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 groups that measured. The one in the middle, half of 11 is 5.5, so the sixth one is going to be our median. And then when we work with the quartiles, we take the halfway point of our lower half, so everything less than the median, 1, 2, 3, 4, 5, means that's the middle number of the lower half. And everything above the median, 1, 2, 3, 4, 5, this is the middle number of the upper half. So these 3 data points make up your minimum, your maximum, your median, your first quartile, and your third quartile. Now, when we look for interquartile ranges, it's like, what is the difference between the highest and the lowest number? That's the range. And what is the difference between the quartiles? That's the interquartile range. So to go from 32 to 33, that's just a gap of 1 foot. Okay, so now let's look at the ruler measurements. Our minimum was 30. Our maximum was 35. So there's the minimum. There's the maximum. Our median is the number that's in the middle. What number is that? 1, 2, 3, 4, 5. The sixth number in is 32 3/4. 32.75, either in decimal form or fraction form, doesn't matter. And then we look at our quartiles. So the halfway point of the lower data is this one right there. And 1, 2, 3, 4, 5. The halfway point here is 34. So the lower quartile or first quartile is 32. The bigger one is 34, giving us a range of 5 feet. And the interquartile range is a range of 2 feet. So just by looking at these numbers here, can you tell which one is more precise? Which one seems to be closer together? I think you could probably tell just by looking at the numbers here, but let's put this data, let's see what it looks like when we put this data into a box plot. Here's our 2 box plots, one for the measuring tape in green, one for the ruler in blue. And looks like you've got your minimum, your maximum, and your interquartile range here. Now the ruler, you've got your minimum, your maximum, and your interquartile range. If you think back to when we were looking at the target with the bullseye, the more accurate was closer toward the center of the bullseye, but that didn't necessarily mean that it was more precise. Here, I think our box plots are kind of giving us an idea of which unit of measurement was more precise. The measuring tape or the ruler, which one are you going to say is the more precise measurement? And if you're saying measuring tape, I agree with you, because the distance between the minimum and the maximum is only 2.5, and this 50% of the data was between 32 and 33 feet. That's making me think that the more accurate measurement puts us somewhere in this 32 to 33 foot range. Here you say 32 to 34 foot. Well, that's a little bit broader of a range. The medians are only a few inches apart. So I think we can confidently say that the room's measurement is 32.5 to 32.75, 32 and 3/4. So box plots, the data from box plots is a good way to test to see what is the spread of the data. The more spread out it is an indicator of maybe less precision. Maybe there's outliers that are showing up in the data. This data didn't really seem to have too many outliers, but it is a nice resource to use to see the spread and to check for both accuracy and precision. So good luck with the homework. My guess is that your homework over the next couple days is going to give you some data, and you're going to have to find averages, look for outliers, put that data into either histograms or box plots. Just do your best. Yeah, I know you worked on it a bit last year in 6th grade. We practiced a little bit this year. We're going to continue practicing it. We are going to get into the Ms. Pac-Man project, where you're going to practice it even further. So good luck with everything, and we'll come back with our next lesson on Wednesday. All right, take care.
Hey, feeling good, like I should. When in dark, walk